Okay, now when we learn about quadratic functions, it is parabolic function. Parabolic function can be differentiated into two parts. It is minimum functions or maximum function, right? So maximum function when the function is opening down. Why maximum is opening down? How come? Maximum is always up. No, maximum is opening down. This will be the maximum point, right? And the minimum point will be opening up. This will be the maximum point. Wait, minimum point. Yeah. And this will be for a of negative. This will be for a of positive, right? So a positive producing minimum value, a negative producing maximum value. That is optimation. And when we are talking about optimation, we also talk about the symmetrical functions, right? Symmetrical axis. From here. We want to find the symmetrical function axis. So what is axis of symmetry or axis of symmetry? We can write x m is equals to negative b over 2a. Okay, negative b over 2a is the symmetrical axis. And when we try to find the symmetrical axis, it is always means symmetrical. It has to be folded equally. For example, here. Okay, that's nice. So this will be our symmetrical axis, right? When x equals something, and they will share the same area. If I close this close, and the area of the left side is equals to the area of the right side, it is called symmetrical axis. So this will be xm, right? xm comma ym. It can be, I write my because it can be either maximum or minimum, right? If I want to draw the graph, I want to switch the graph by like this. Wait, not good. That's better. So this will be also a symmetrical axis. Where is the symmetrical axis? It is located here. Has to be as neat as possible. No, it's not too. It's not symmetrical. A bit to the right. Sorry, I am a bit OCD here. There you go. So this will be the symmetrical axis. It is xm, comma ym, but the m stands for maximum. Here the m stands for the minimum value. That's the optimal or optimal or either optimal can be two again, minimum or maximum value. This will be what you will learn in the optimation. Okay, negative b over 2a. How come it is negative b over 2a? That's the formula. Okay, so I will send you this. See, I also teach symmetrical value, but in Sphk 1. Sphk 1 means in Tanjung Duren. See, they also teach talking about x, m, y, and just now. So I will put a new one, and this is called optimation. So let's look at look at your book. Wait, your book is here. Maths, education, materials. Wait, I am lagging right now. My brain is lagging. Books, GCSE. Oh, yeah. 0606, right? So what topic I forgot, Tidra?
Quadratic optimization.
Then H.
3H.
Okay, thanks. Yep. See, we have x negative b over 2a. It can be y minimum and it can be y maximum. And the formula always negative b over 2a for the x intercept. I mean x symmetrical x. So find maximum or minimum value of the quadratic function. Okay, later we just put the formula x equals something, right? X equals negative b over 2a, And since A is less than 0, remember, A is less than 0, the shape is frowning, set face, and set face is the maximum, right? This set face maximum, smiling face is minimum. When you smile, your lips going down, right? When you frown, your lips going up. I don't know how to explain that, but that's the idea about formula. Let's see for word problem. I want to discuss, we will discuss about exercise 3H, everything. Okay, because we have so much time and this is quite simple because we are talking only about optimation. So the main formula is negative b over 2a. Now for question 1a. Before you do, determine the a, b, c, right? That's how I try to explain to all my students and the following students about how to find the maximum or minimum. Again, you write A, B, C. Oh, we don't have the C, you just write 0, right? We don't have the C, ax squared, 1x squared, minus 2, negative 2, don't forget. And then part B also, part B, okay. This is quite random. The position of A, B, C are not in order, but you know what is A? The formula is y equals ax squared plus bx plus c. So A is for the coefficient of x squared, b is for the coefficient of x, c is the independent or the term itself, the constant term, right? A equals negative 1, negative 2, 7. How about c? Okay, I don't do the question yet. I just try to separate all the A, B, C. That's how we work. It is less stressful. Okay, no need to put plus 2 here. A is x squared, bx plus c is 8, right? So what to do? Find the maximum or minimum. Okay, so since A is positive, smile, frown, frown. Look at the value of A. And this will be the minimum, maximum. So you have to determine whether it is maximum or minimum, not only about the answer. This is the minimum. Sorry, maximum, right? Because it's on top, on bottom, right? So what next? Okay. Oh, find the value of x. Negative b over 2a. Xm. It can be either maximum or minimum. In this case, or for question A, x minimum. So we skip def later on. We can do def later because we don't have enough space here. See, so it is so neat and so easy to look. Right, negative b minus 2. Okay, xm. Wait, minus 2 over 2 times 1. So it is 1, right? And then how about this? Minus b minus 2 over 2 times negative 1. 2 over negative 2, it's negative 1. The maximum is on the negative 1, but it's okay, no problem. Don't think about, oh, maximum is supposed to be positive. No, it's hell no. So the maximum and minimum can be random. Okay, it can be either positive, negative, and else. Depend on the question, of course, the ABC. Minus b over 2a. Okay, this is fraction. Minus 2 over negative 6, so 1 over 3. After you get the xm, what you next do is try to find the y, right? How do you calculate the y? Just insert into the formula. What is the formula? Here, y equals x squared minus 2x. For question B, y equals 7 minus 2x minus x squared, right? I just rewrite the number, the functions. Let me know whenever you have any questions. Here, x squared. So why I do this? Because we do 3 questions in one row, one period like this. Okay, one flow. Okay, so you just put the xm to the y. That's the idea. So the ym will provide it when you put the xm inside the x, or you substitute xm to the x. So 1 squared minus 2 times 1, negative 1. All right, make it fast. 7 minus 2 times negative 1 minus, okay, we cannot do fast like this. 7 plus 2 minus 1. 8. Next, 8 plus 2 times 1 over 3. Man, fraction. negative fraction, and we cannot get rid of the fraction. So 8 plus 2 over 3 minus 3 times 1 over 9. And I have the best tools to do calculator. 8 plus 2 over 3 minus 1 over 3, right? The answer is 8 1 over 3. So later on we will prove whether it is maximum or minimum, and we will use the tools to graph to draw. So the what you call. Okay, done. This will be the answer, right? Y is the value. Okay, this will be your answer. And let's try to prove it in GeoGebra. So for number 1, A, B, C, the answer is -1, 8, and 8, 1 over 3. For minimum, maximum, and maximum. Why? Because you have to look at the value of A. When A is positive, it is minimum. When A is negative, it is maximum. Let's prove. Wait, do I share all the screen? Yes, I do. GeoGebra. Let's prove one only. No need to prove all. But I think we have to prove all because it's quite simple. Number 1, x squared minus 2x. Okay, minimum. And the minimum value is -1. It cannot be less than -1, and it is minimum, right? See, minimum -1, minimum and -1. Find the value of y only, and the x is 1 already given. Also, it's provided completely -1, 1, and this is the turning point. And for the next question, okay, 7 minus 2x squared minus x squared. 7 minus 2x squared minus x squared. Okay. 7 minus 2x squared minus 7 minus 2x minus x squared. Sorry, 7 minus 2x minus x squared. Turning point is 8, -1, 8, and it's maximum, right? It's on top. -1, 8 on top. -1, 8 maximum. See, the curve is equal. It's the same. Yeah. And for the rest also, we already proved 2, so we don't have to prove everything. Okay, that's for number 1, A, B, C. Do you understand so far, Tedra?
Yeah, I understand.
Okay, nice. So for D, E, F, we just skip it. Why? Because it's the same, totally the same. Just mention the A, focus on the A. This is what you have to think further. Whether maximum or minimum. Maximum when A equals negative, minimum when A equals positive. Okay, so number 2 right now. We try to solve number 2. I will copy this. And I will put it here. Yeah. 2 for the word problems. Okay, the profit of manufacturing, see, profit. You have to find the maximum profit, right? So the question is always like that. What is the minimum total profit? I mean, how many refrigerators should be made each day to minimize the total profit? That's a wrong question. I can tell you, that's the wrong question. Why? Because profit is to be maximized, never be minimized. And the A is already negative. When A is negative, rounding, it has to be maximized. No minimum. The minimum is nothing. We can go further and further and further and further, right? So when A is negative, the question has to ask you to maximize. If it is minimized, question is wrong, right? So P, so the profit P equals, I read that one more time, 240x and minus 800. And how many refrigerators should be made each day to maximize the profit? So when I want to maximize the profit again, you have to find the x m, negative b over 2a. But before that, I forget to think to determine which is A, which is B, which is C. That's for the step only. This is for my OCD satisfaction because I cannot look at A, B, C too much, too mess up. So XM would be negative 240. So in order to find the maximum profit, so this can be changed into Y, right? Yeah. So negative 240 over 2 times negative 3. So negative 240 over negative 6, it is 40. So what is the X? Refrigerators. So we already get value of A. 40 refrigerators would be made each day, should be made each day to maximize the total profit. Okay. If it is more, sometimes you think that, okay, in one company, when I make more product, I can get the more profit. Not necessarily like that. Let's see. Negative 3x squared plus 240x minus 800. When you do more refrigerators, when you create or when you try to produce more refrigerators, I have to maximize all the refrigerators. That's the wrong thinking. So pay attention. This is so useful. This is so important in your manufacturing process later on. If you work at that at manufacturer or in a factory, be careful. More products not always means more profit. Why? Because when you make more product, you have to add another extra cost, right? For example, your labor cost. You have to uh, make the extra effort for labor, and you have to make what else? At the amount of labors, at the work hour, and overhead cost, and so on. So it is not effective anymore if you create more than if you try to produce more than the maximum amount or maximum amount of the product to maximize total profit. So again, mm, the amount of refrigerators cannot be linear, cannot be what do you call directly proportion to the amount of total profit. Pay attention on that case. If I make more 40, let's try. P equals negative 3x squared plus 240x minus 800, right? Wait, it's not 800. When I put 40, what is the profit? Negative 3 times 40 squared plus 240 times 40 minus 800. And the answer would be, wait, I'm counting. It's too much if I count it manually. The profit is 4,000. Okay, let's prove. If I increase the amount of refrigerators, do I get the more profit? Not necessarily. Why? Because we have the negative here. So this will be the subtractor. And let's try 50. Right? Or 41. Better 41. I increase one more production. One more product to be produced. 800. Let's try to find the answer. Negative 3 times 41 square. So now I will give you the sense of understanding about this. 3,997 Tedra. So it's not maximum, right? This is the maximum. And if you decrease, how about P39? So okay, so the less the product, the less the more the profit. Because if I decrease the product, see, I will assuming I will increasing the profit. Let's try. If I put negative 3 times 39, see, let's try. 240 times 39 minus 800. Is it 4,000 also? Is it more than 4,000? Let's try. Negative 3 times 39 square plus 240 times 39 minus 800. Oh, 3,997 also. See? So this is the maximum, and no doubt. Why? Because when you look at the graph, this is extra, yeah, extra. I don't think your teacher will teach you this, but I hope that your teacher will teach you this. Again, I'm trying to give you the more broader perspective about this. So what is it? y equals, not p, yeah, because the GeoGebra can understand y and x only. Negative 3x squared, and then plus 40x plus 800. Wait, it's 8 plus minus 800. Okay, too much. And see, there the maximum profit is 400, 4,000, and with the turning point of 40 amount of refrigerators. Got it? See, do you have any questions so far, Pedro, for question A? Why it cannot be less or more? Because it is a function. Okay, quadratic. Understand, Pedro?
Yeah, I understand.
Nice. So P equals, yeah, we already did that. Negative 3 times 40 squared plus 240 times 40 minus 800. The answer is 4,000. Okay, that's for the answer. Is it? Dollars. Okay, continue, yeah. So no need to talk about this too much. And try to do number 3. Rectangular plot. Okay, this is more challenging question. A rectangular plot is enclosed by 200 meter of fencing. Okay, fencing is always talking about perimeter, right? It is perimeter. When we talk about fence, fence cannot be put here, right? Fence is always on the edges, on the perimeter. So if we have x, this is x. Okay, so A has an area of A square meters. Oh my goodness. So what is 200 then? 200 is the breadth plus length plus breadth plus length, right? Oh, so conservative. Too much. 2 times L plus B, right? So we know that the breadth is X already. So just divide this by 200. So become 100 equals L plus B. Can I simply put like that? And then we know that the 100 equals length plus X. So we know that the length is 100 subtract X. Put it here, right? So we use the perimeter rule in order to find the length in terms of X, right? Find the length in terms of X. So 100 minus X. Or you can just think simple. 200, okay, 200 is already, oh, half of it will be 100, right? Because 200 is the blue color plus the red color. You can think like that also. Okay, so either blue or red is 100. So this is 100 minus X. What is the area? So area is length times breadth, right? Length times breadth, right? So 100x minus x squared. Done. Proven. We show that this. And the area is maximized if the rectangle is a square. Okay, let's try. We want to maximize this, right? So the A will be -1, the B will be 100, the C will be 0, right? And then the xm will be -b over 2a. That's the formula that you have to memorize, right? So -100 over 2 times -1. -100 over -2, 50. See, if x is 50, this also 100 minus 50, 50. So this will be a rectangle, a square. So it is proven. So when xm equals 50, so the width is also 50 and the length is also 50. This called when the width is equals to the length or breadth, sorry. I have to use one thing. Breadth is 50. The length is also 100 subtract 50, right? So this will give you the notion of a square because they share the same base, the same side. Breadth equals length. Okay, that's for number 3. Now we do number 4. Let me know whenever you have any question, anytime. Cut my explanation. That's better. Okay, rather than oh, okay, this will be. Oh no, wait, number 4. Three sides of a rectangular paddock are to be fenced, the fourth side being an existing street water. If 1,000 meter of fencing is available, I cannot imagine the drawing. Wait, we have the water, we have water drain, and three sides of a rectangular paddock are to be fenced. Rectangular paddock. Okay, we have three sides. 1, 2, 3, rectangular, 3 equal. Means equal, it cannot be different. If it is different, we cannot imagine the question. And then the fourth side, oh, okay, this is one, first, second, this is the first, second, third, fourth. The fourth side being an existing street water drain, so you don't have to put fence. You put fence only here. Okay, and this will be X. And this also something, right? So Y, for example, oh, okay, this is the length, this is the breadth, right? You don't have to think about this. So where is the fencing meets? Fencing is about here. Wait, I have to think first. This is the water, so you don't have to put anything here, right? The fencing is about here. Okay, the red color. The blue color will be water drain, street water drain, so you don't have to think of to put the fence on the water, right? Inside the water. So 1,000 equals to 3L plus 6B, right? Okay, and I cannot do anything else about this because I don't know the direction. Okay, use the I see. I think I did something wrong. There are three sides, not three rectangles. See here. I have the water drain here, so you don't have to put any fencing. And I have the fence put it here. Three sides. Side number 1, side number 2, side number 3. That's it. This is X, for example. I'll just put it width. This is the length, right? And 1,000 is length plus width, because that's the fence. Fence is always on the perimeter. So 1,000 equals 2L plus W. So you can write the W is 1,000 subtract 2L, right? That's the easiest way, rather than 2L equals. That's how I think. How about L equals 3? It's too hard. L equals 1,000 minus W over 2, wasting time, right? It was so wasted. 1,000 minus W over 2. Okay, it's too complicated. I think we better use this. Okay, so find the dimension to maximum possible area, to maximize the area. So what is area? Length times width or breadth. It's the same. So length times 1,000 minus 2L, right? You just switch the W or substitute the W by this. So area equals 1,000 L minus 2L squared, right? So if you want to maximize the area, again, you can think of this part. Y equals 1,000 x minus 2x squared. That's the easiest way to do because we learn x, y, not a and l, right? A and l is only symbol. So x m will equals to negative b over 2a. Okay, forget a equals negative 2, b equals 1,000, c equals 0, right? So negative 1,000 over 2 times negative 2. So it has to be negative 1,000 over negative 4, right? So it is 250. 250 meter, right? And then after you get 250 meter, wait, did I do something wrong? Yeah, that's it. So After you get the x maximum, so that's the L, right? I just changed the x by L. So the length will be 250 meter. And then the width will be 1000 minus 2 times 250. So it is 1000 minus 500, so 500 meter. So the dimension of the width is 500 meter and the length will be 250 meter. Okay. The total is 1000 also, right? 1000, 250 plus 250, 500, 500 plus 500 is 1000. 1000 meter of fencing is used, and also the area. Is the question asking you for the area? No. Okay, just only the dimension. That's it. Okay, if you want to do further, what's the area? So width times length or length times width. 250 times 500. 125,000. 125,000 meters square if you are asked. But the question is not asking you that. The question is only asking you for dimension. That's it. This only the answer. Okay. Let me know whenever you have any question again, because this is so very various. The question can be different for the next also. See, 1,800 fencing. So to fence 6 area, 6 part of rectangles. So this requires again a lot of working, but try to think systematically. If you think systematically, it's quite simple. Okay. 1,800 fencing is available to fence 6 identical pens as shown in the diagram. 1,800 is this fence. This one, this, what I draw, yeah. There you go. So the total length of the fence is 1,800 is to cover y. How many y we have? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Right? 8y. Plus, how many x we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you are asked, explain why this. Can you explain it? I cannot explain it well in English. How's it, Pedra? Can you explain why 1,800 equals to 9x plus 8y?
I don't really know how to explain it either.
Me too. But you know how, right? You know how to make sense of this, right?
Yeah, it makes sense, but I don't know how to explain it.
Yeah, me too. That's my problem also. So why 1,800? 9x plus 8y equals 1,800. Okay, so we need at least 9 width of each of the rectangles, right? And 6, it's the six length. Wait, not 6. 8 length of the rectangle, right? 8 of this, so 8y. And 9 of this, so 9y. Okay, that's it. No need to think further. Now show that the area of each pen is given by how come? Show that the area of each pen is given by, oh, it's supposed to be x times y, right? So each pen here. So pen area, one area, each area is equals to x times y. But they they don't give you the y, so you just substitute the y, right? So 8y equals 1,800 plus minus 9x, right? And then y equals 1,800 minus 9x over 8. Now the area will be x times 1,800, or I can just simply factorize this first. It's too hard. 200 minus x over 8. And then x times y, right? So y, just substitute y to the left side. 9, 200 minus x over 8. Cool. And then x times 1,800. What the heck? Oh, okay. X times 9 is 9x, sorry. Okay, it's getting easier. Minus x over 8. So cross multiply, rainbow multiplication, 1800x minus 9x squared over 8. So what is 1800x over 8? Man, complicated. So 1800 over x is supposed to be 225. Yeah, that's it. 225x minus 9 over 8x squared. It's just switch, right? Okay, it's the same. Just switch the order. So it's proven, yeah. How to do C? If the area is to be maximized, what are dimensions of each pen? So what is x, what is y? So the area would be negative 9 over 8 x squared minus plus 225x. If you want to maximize, you have to find the x as negative b over 2a, right? Negative 225 over 2 times negative 9 over 8. Okay, so negative 225 over 2 times negative 9 over 8. 100. Oh, it's cool. It's a good question. 100. Good answer. So x is 100. What is the y then? So where is y? Where is y? Where is y? Oh, it's beside. Right. So just substitute 9 times 200 minus 100 over 8. Because the x is 100, you put it here. So the y will be 900 over 8. Right? Crazy. It's hard. 112.5. So this will be the dimension 100 meter and 112.5 meter. Okay. So again and again, this will be so complicated, and yet we just use some formula, substitution, right, and so on. Okay, now maybe I will give you one or two more questions because let's try to do question. Oh, no, three more numbers. Maybe I think we can do number 8, number 6. Okay, I have to think it first because I haven't seen this kind of question. I found the fencing available to make 4 rectangular fence. Find the dimensions. Oh, okay. If the plan is A and the plan is B. Okay, so we have two questions in one number. So focus on A first. Yeah. I want to copy A. So this is 500 fencing available. Okay, so for example, let's let the length be X. Okay, no need one line, satu aja. Okay, and this is what. So how many X we have? 1, 2, 3, 4, 5, 6, right? 6x plus 1, 2, 3, 4, 5, 6 y also equals 500. You can divide by 2, right? So 3x plus 3y equals 250. And the area of each pen is x times y, right? Each pen. It's the same, but yeah, you have to do it then. 3y equals 250 minus 3x. So y will be 250 minus 3x over 3, right? So the area will be x times 250 minus 3x over 3. And then area equals 250x minus 3x squared over 3. You have to do it slow, but sure. So the area will be 250 over 3x minus x squared. And the A is -1, the B is is 250 over 3. So we know that the xm, negative b over 2a over 2 times -1. So 125 over 3. I just make it simple like that. And when xm equals 125 over 3, so the x will be, and the y will be put here. 250 minus 3 times 125 over 3 over 3. And it is again a square, right? You can cross this. 125 over 3. See? The same. So area of each pen for question A, for type A. X times Y. Okay, you can get the answer by yourself. I'm too lazy. Now, how about this? So let this will be x, y, and this will be x, right? So how many x we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 x. Plus how many y? 8y. See, it's different. But also, we have 500, right? And then we cannot do further. So 8y equals 500 minus 5x. So 8y equals 500 minus 5x over 8. And you have to find the area of the fence for question B, right? So area will be x times y of each pen again, x times, wait, forget to erase the 8 times y. 500 minus 5x over 8, and then we put 500x minus 5x squared over 8. So the area will be 500 over 8x minus 5 over 8x squared. And the A is negative 5 over 8. The B will be 500 over 8. I hate this because this is fraction. But again, we have to find the x maximum, right? To maximize the area, xm equals negative b over 2a. So negative of 500 over 8 over 2 times negative 5 over 8. Okay, again, we use calculator. Wait, yeah. 50. Oh, it's good answer. 50. And the y will be here, put 500 minus 250, right? Or minus 5 times 50. Okay, slowly. So 50 also, right? So it's again a rectangle. That's it. So the answer of question A, 125 over 3 and 125 over 3 for x and for y. And about this, 50 and 50 about x and about y. Okay. Any questions so far, Tedra?
No, it makes sense.
Makes sense, yeah. Thanks. I'm glad to hear that because it's so hard. And I think we can do 8 because number 7 is totally different. Number 7 is not about maximum vertical. Oh, maximum vertical separation, no need for it. I think we do number 8. One more, yeah. Okay, let AB be x and BC equals y. Use similar triangles to find y in terms of x. Similarity. Okay, we have ABCD here. Similar triangle. Oh well, wait. Oh, we know. And this is 10, right? Because we deal with right angle triangle. Yeah. So if it is right angle triangle, you have to put Pythagoras rule. Right. So it is 10 centimeter. Right. And then let AB be x and BC be y. Find in y in terms of x. So I put x. Wait, don't put x. I put A, B, C, D, E, and F here. So triangle BCF is equals to triangle EDF, right? I mean, similar to EDF. So if I want to find the area BC over EA equals, wait, this will be 8 minus x, right? Equals CF over ADF. See, the smaller one over the bigger one equals the smaller one over the bigger one. BC over ED, EA, not EA, see? BC over ED. BC over ED equals to CF over DF, right? So what is BC? BC is Y. What is ED? 6 equals, what is CF? 8 minus X over DF 8. So you can find Y in terms of X, see? So you can just write the cross multiplication rule. 8Y equals 6, 8 minus X. So 8Y equals 48 minus 6X. Okay, you can divide everything by 2 before you do further. 4Y equals 24 minus 3X. So Y equals 24 minus 3X over 4. Done. For question A. Find the dimension of rectangle ABC of maximum area. Okay, maximum area of ABCD, X times Y, right? What is X? X itself. What is Y? This, right? Okay, slowly. 24X minus 3X squared over 4, or 6X minus 3 over 4X squared. This is the B, this will be the A. And you can find the XM by putting negative B over 2A, right? And then next, put on the number, you get the XM, and you can find the Y by putting the X here. And you can find the dimension, that's it. I don't want to continue because it's too hard and too much workings. But you can do it. I know you can do it because we already did this on the previous question. Okay, I will end this meeting. No, I will pause the recording